So dear student, today we have to start the next unit, that is coagulation and flocculation. Okay, and we have to study the filtration part also. Just wait. We have studied the sedimentation part, and we have discussed the types of sedimentation, which is horizontal flow type of sedimentation. Okay, that having different shapes, rectangular shape and circular shape, isn't it? So today we have to study coagulation, which is very much important, as you know, water is having chemical property. Okay, so just wait. So, dear student, very fine suspended particles are not removed by plain sedimentation. We have studied that plain sedimentation, which is to be removed by gravitational force. So silt particle, which it is observed and it is surveyed that silt particle means clay particle, which having 0.06 mm size, which requires 10 hours to settle. You can see the image in that suspended particles or the silty particles are in suspension motion, isn't it? So it is observed that if that size is having 0.06 mm, and we have to settle down for the 3-meter deep sedimentation, plain sedimentation tank, which will require 10 hours to settle down. And if the particle which is more or less that is nearly 0.02 mm particle may require 4 days for settling. Okay, this settling time is it practically possible? We cannot wait such a longer time, isn't it? We cannot wait such a longer time because we have to carry out its purification properly and effectively within time. Okay, so in addition to fine particles of suspended matter, whichever present in that raw water, which are electrically charged, electrically charged. So that electrically charged colloidal matter, which are continuously in motion, zigzag manner मध्ये ते फिरत राहतात पाण्यामध्ये. Okay, so they never settle down due to gravity, or if they may settle down, it may require larger time. Okay, so which is not practically possible. So that matter contains such fine clay particle and colloidal, it becomes necessary to apply certain different process. So that process can easily remove from water such impurities, can be carried out into that raw water, that is nothing but sedimentation aided with coagulation. Okay, so what is the definition of coagulation? Are you hearing me? Hello? Hello? Hello, participants, can you hear me?
Yes, ma'am.
Okay, so you have to understand the definition of coagulation. The term coagulation is actually derived from a Latin word, coagulare. Coagulare. You can see the coagulation term. In that, coagulare is the term, which is a Latin word. Okay, which is nothing but the meaning of coagulare is drive together. You have to drive together, म्हणजे एकत्र आणणे. Okay, so colloidal particle carry electrical charges on them. Okay, electrical charge त्याच्यामध्ये असतं. So, and as such, they are in continuous in motion. Continuous motion मध्ये ते असतात. आणि जसं मी I have told you that if you have to carry out settlement of those particles, due to gravity, they cannot settle down. Okay, so these colloidal result in stable suspension, as I have shown you in this image. Stable suspension. तरंगत राहतात ते zigzag manner मध्ये इथे फिरत राहतात. Okay, so suspension motion they may carry. So in general, suspension stable enough so that gravity force will not cause their precipitation. Okay, of this colloidal particle. I'll show you the different image so you can see the solution. Okay, and the suspended particles are in suspension motion. Okay, after certain time precipitation takes place, but This is effectively carried out for larger particles, for larger suspended particles, which we have seen in plain sedimentation. But colloidal particles have their charge particle that have elect that means negative charge particles they are. So we have to understand what are colloids. What are colloids? So we'll see that part. Okay. So that special treatment may remove from that aqueous phase, that is destabilization of colloids. म्हणजे काय न्यूट्रलाइज करायचं आपल्याला निगेटिव्ह चार्ज जे काही particles आहे निगेटिव्ह colloidal particles which may present in clay silty particle. So we have to carry out certain thing, certain chemical process so that they get agglomeration. They will carry out their accumulation, or we can say driving together. Okay, so that is destabilization of colloids is nothing but coagulation. Okay, so please send to other students to join. This coagulation is a little bit, you have to understand the chemistry behind that. Okay, so please put a message on your group. Other students can join. Okay, so what is the definition of this coagulation? The, as I have told you, the process of mixing certain chemicals. We have to add addition of certain mixing of certain chemicals to water to neutralize electrical charge and to form an insoluble gelatinous flocculent precipitate. Insoluble gelatinous flocculent part which may precipitate for absorbing and which may entraining suspended and colloidal particle of such impurities. That is nothing but coagulation. That is nothing but the destabilization. This word destabilization. Okay, that means neutralization of those colloids is nothing but the coagulation. Okay, so you have to understand what are the types of colloids. What are the types of colloids? नेमके colloids काय असतात? So you have to understand. Brownian theory, Brownian motion, Brownian theory. We have to understand. So related to this, we'll discuss. So I have told you why we have to carry out this coagulation process. If we will not carry out this coagulation process, we will face a lot of problems in filtration process. Okay, so when we will carry out filtration, that means we have to make uh, filter beds arrangement into filtration bed. In that, tables, different layers, coarser material layers are there, and if that colloidal particle are settle into that, it may create lots of issues into maintenance of that filter beds, and it will increase the expenditure of your maintenance and your complete project. Okay, so we have to remove those colloidal particles. Okay, so that individual colloid must aggregate and grow in size. So we have to study for this. So dear student, what are the types of colloids? So colloids have size of 10 raised to minus 3 to 1 micron size. Okay, somewhere they are in the range, or some bacteria may present into that. Okay, 50 to 70% of organic matter in domestic wastewater, which is composed of colloidal matter. Okay, if we think about the wastewater, so in that colloidal particles are organic in nature. And in water treatment, odor, turbidity, and viruses, bacteria, algae, and organic material are primarily either in colloidal form and behave as a colloids. Okay, so what this is very micron size, 10 raised to minus 3 to 1 micron. So you can see this image. In this, micron sizes are viruses, humic acids, algae. They are having very small size, and so those smaller size particles are in suspension, continuously in suspension. जसं तुम्ही बघते ना, काळी माती असते, काळी मातीमध्ये फायब्रस मटेरियल असतं. ते फायब्रस मटेरियल जे असतं किंवा क्लेई पार्टिकल असतात ते सेटल व्हायला खूप त्रासदायक असतात. सो दे आर हॅव्हिंग साईज 0.1 to 1 micron. Okay, so particles which are just big enough to have surface which is microscopically observable, म्हणजे एकदम micron size असतात. And we have to think about how to uh, make coag make flocculation of those particles. Okay, so that's why we have to understand colloidal stability. Okay, so causes of colloidal stability. Colloidal stability can be influenced by degree of affinity for the solvent in which colloid is suspended. So these leads of following colloid classification. So what are the types of colloids? Okay, colloids have two types. Hydrophobic means water hating and water favoring. Okay, water loving. So those are two types colloidal classification. That means what is hydrophobic? Hydrophobic means these colloids are not, which having negative charge and dispersion is stabilized by electrostatic repulsion. Means clay particle, sulfides, then metal oxides, the substance ferrous oxide, then you can see the chlorine oxide. So these chemicals which having clay particle which having negative charge particle. Okay, they are electrostatic having repulsion, जे ते दूर जातात एक दुसऱ्याच्या दूर जातात because they are having same negative charge. Okay, so they are irreversible. Okay, which means they have to enough they need a certain time to settle down. Okay, but they never get settled down because of same charge. Okay, how they will see in this image, negative surface charge. So colloid having which are in the negative surface charge into the water, they are carrying repulsion because of Brownian motion. They get separated to each other because having same charge. Okay, one colloid A and colloid B, they are having negative charge, so they distracted to each other. They cannot attract it to each other. The repulsion is present into both the colloid. Okay, so we have to carry out its attraction. How this attraction will take place? So for that we have to carry out certain process, certain chemical addition, so that it will get attracted. Okay, so colloid stability is very much important. So those negative charge particle, they repelled to each other. Okay, so there is impossible to having their agglomeration. Okay, where due to gravity. So that particle are hydrophobic. And next is the whatever the particle which are attracting water, they love water. So those are you have to understand what is that colloid particle. So some in water some gelatins, starch, proteins type of material, organic material is present. So those particles are attracted to water. Okay, and these particles are thermodynamically stable or reversible. Okay, they are having certain charges. So whatever the condition that takes place, chemical reaction will take place into the solvent, into such types of material which are gelatin, starch, gelatin. So organic content, proteins, they are having certain charge, and they will react spontaneously from colloids in water. Okay, so they attracted to the water. Okay, so this is the type of coagulation. So coagulation is nothing but aggregation of colloidal particles which can be considered which having two separate distinct steps. What happened? First of all, you have to understand what is this flocculation, and then what is coagulation. So when particle transport to effect interparticle collision, means first of all, when this complete coagulation will take place at that time, you have to understand how this charge particle will carry out their action. So in this, the flux formation is takes place and electrical charges are very much important. So when certain chemicals when added into the water, an insoluble gelatinous flocculent precipitate is formed. So this gelatinous precipitate during its formation and it will descend through water and which will entangle म्हणजे काय करतं ते फाईन सस्पेंडेड पार्टिकल्सला आपल्याकडे खेचून घेतं अट्रॅक्ट करतं and colloidal impurities will be entangled. They are forming gelatinous mass. Gelatinous म्हणजे एक छोटासा एक फॉर्मेशन होतं त्याला आपण फ्लॉक म्हणतो. So coagulants further may have advantages removing color, odor, as well as taste from water. Okay, so electrical charges, ions from which possess positive electrical colloidal particles, negative charge ions, they get attracted. Okay, the flock thus attracts colloidal particle and make them settle down. Okay, so electrical charges may play very much important role. So flocculation and coagulation, they are carrying out their action in both the ways. Okay, so what is flock formation? As I've told you, coagulant म्हणजे जे आपण ऍड करतोय केमिकल त्यामध्ये पॉझिटिव्ह चार्ज असतो. ओके, से फॉर एक्झाम्पल अल्युमिनियम सल्फेट, alum. Okay, alum in your daily activities, alum is added into the water. Your mother is used this alum for carrying out its settlability of colloidal particle. Okay, सगळ्यांना माहिती आहे तुरटी, तर तुरटी यूज केली जाते टू ऍड whatever to carry out coagulation. That means whatever the charge, negative charge particle, that means clay, silty particle, they get attracted to the positive your chemical coagulant. Okay, alum have positive charge particle and colloidal particle have negative charge particle, so they get attracted to each other and flock formation is present. Okay, so flock formation takes place. So when coagulant is added to water, it is mixed thoroughly and thick gelatinous block is formed. Thick gelatinous block is formed. So as block settles down, it attracts an erased colloidal particle. Are you understanding? म्हणजे जेव्हा आपण तुरटी टाकतो, तुरटी मिक्स केल्यानंतर एक केमिकल रिएक्शन होते. Chemical reaction is very much important, which takes place when we are adding this type of coagulants. Okay, so thick gelatinous block is formed during when we are adding such chemicals, and as flock settles down, तो जो काही गाळ असतो तो सेटल डाऊन होतो, प्रेसिपिटेशन तिथे फॉर्म होतं आणि अट्रॅक्ट करतं ते कोलायडल पार्टिकलला आणि त्याला सेटल करण्यासाठी मजबूर करतो आणि ते सेटल होतात. ओके, सो दॅट इज फ्लॉक फॉर्मेशन. So principle of coagulation is nothing but the coagulant we are adding to water to remove suspended very fine particle, that means colloidal particles, which depending upon the complete turbidity of water. So turbidity is very much important. Turbidity, how much turbid water is there, how much colloidal and suspended particles are there, that we have to check. Its pH and turbidity we need to check. So either you can see the turbidity is in higher range. If heavier suspended particles are there, then you must to carry out plain sedimentation, and after that certain colloidal particles may not settle due to say plain sedimentation, so you need to carry out its coagulation. That means you have to add chemicals into that for their agglomeration, their precipitation. So that is carried out through the flash mixing. So means chemical you need to add. Okay, so coagulation is destabilization of colloids by addition of chemical that neutralize the negative charge. So you can see the chemicals are known as coagulants, which are higher valency. You can see aluminum sulfate, as I have told you, aluminum sulfate, ferrous sulfate, they are cationic salts. Okay, their valency is 3 plus, Al3 plus, Fe3 plus. So valency is greater. So they are having higher valency and they can attract certain clay particle, so, your city particle, which are having negative charge particles, very fine suspended particle, as well as colloidal impurities. So we need to carry out this action in a effective manner so that coagulation will be carried out in a very nice manner. So what is the action? What is the theory behind this coagulation? So in that, double layer theory will act. Diffuse double layer theory. Okay, so you have to understand what is this double layer theory. Means what is the model of that colloidal particle? How it will take place. So that we have to understand. So you can see the image charge neutralization. See, if the colloidal particle only present into the water, as I have shown you in the first image, they are in continuous in suspension form. Okay, they are having large repulsion force between both, between two colloid particle. Okay, so they are having large repulsion force. They distracted to each other. They cannot attract to each other. So we have to understand a large repulsion force there in between both. So we need to add certain chemical. So usually we are adding aluminum sulfate. Cheaply available आहे तर आपण ते ऍड करतो अल्युमिनियम सल्फेट. तर अल्युमिनियम मध्ये थ्री मोर बॅलन्सी असते आणि त्यामध्ये एक फॉर्मेशन होतो. तर ते काय असतं Al3+ and negative ions, they are attracted to each other and there will be a formation of new hello. So they are carrying out their agglomeration. That means gelatinous mass is present. Whenever this fine suspended mud particle and colloidal particle cannot settle down in this sedimentation process, we have to add certain coagulant. So what happens? They are increasing their size and whatever the flock present, so chemicals are attract. Chemical हे जे chemical आहे ते त्याला attract करतात. ओके, तर केमिकलला काय तुम्ही बघता Al3+ चार्ज आहे, प्लस आणि निगेटिव्ह हे दोन्ही अट्रॅक्ट होतात. ओके, पॉझिटिव्ह चार्ज अँड निगेटिव्ह चार्ज they are attracted to each other and due to this Brownian motion they are repulsing each other, but after addition of coagulant they attracted to each other and reduce repulsive force, as you can see this in this image, and this action takes place into the water, into the raw water. So which is nothing but the which is nothing but the colloidal model, colloidal particle model, that is the diffuse double layer theory. So what is that diffuse double layer theory? We'll see in the next part. See, you can see in this image one container is there. Impurities, that means colloidal particles they are dispersing into the suspension form and they are dispersed complete into the raw water. And chemical we are adding, coagulant we are adding, say for example aluminum sulfate, we are adding into that, which is in powder form, either may powder or either in liquid form, whatever. So when we are adding that coagulant into the water, then diffuse double layer theory will act. So coagulant form is precipitate and trapping impurities. Okay, sorry, trapping impurities. So they are carrying out their action, they're attracting to each other, and then your agglomeration is carried out. So whatever I have told you, gelatinous flock or gelatinous precipitation is trying to develop into this. Okay, so that precipitate and trapped impurities settle to the bottom. I hope through this image you can understood coagulation theory. Okay, so in the same way you have to understand this is the negative charge particle, म्हणजे तुमचं जे असेल ना colloidal particle ते आहे. When we are adding aluminum sulfate into this, aluminum sulfate have, suppose we have considered the aluminum, they are having more valency, 3+ valency, they attract it to the colloidal particle and stern layer is present. स्टर्न लेअर. तर स्टर्न लेअर काय असतं ते आपल्याला बघायचं आहे. After this addition, aluminum will attracted to this colloidal particle and they get neutralized. Positive, negative charge neutralization is takes place, and stability will carry out. Okay, so neutralization is very much important into this process. So this process have certain chemistry behind that. That is electrical double layer theory. Electrical diffuse double layer theory. So how it takes place? If you put charged particle in suspension with ions, then primarily charge will attract counter ions. म्हणजे काय, अपोजिट आयन्स त्याच्यामधले असतील. पाण्यामध्ये टर्बिड वॉटर आहे, गढूळ पाणी आहे, त्याच्यामध्ये आपण काय ऍड केलं, केमिकल ऍड केलं, म्हणजे तुमचं अल्युमिनियम सल्फेट ऍड केला. एक्झाम्पल आहे, टाइप्स ऑफ कोॲग्युलंट खूप आहेत. त्यामध्ये फेरस सल्फेट्स असतं, म्हणजे अल्युमिनियम साल्ट्स असतात किंवा फेरस सॉल्ट्स असतात. तर त्याच्यामध्ये पॉलिइलेक्ट्रोलाइट्स आहेत, डिफरंट केमिकल्स आहेत. यामध्ये तुम्हाला बऱ्याच मध्ये फेरिक सल्फेट वापरता येऊ शकतं, अल्युमिनियम सल्फेट वापरता येऊ शकतं, डिफरंट आहे, कॉपरस आहे. सो डिफरंट टाइप्स ऑफ कोॲग्युलंट्स मे देअर, बट easily and cheaply available ferrous sulfate we usually use for this coagulation purpose. Okay, so when we are adding that coagulant into the water, सगळ्यात आधी काय होतं, अपोजिट चार्ज पार्टिकल जे आहेत ते अट्रॅक्ट होतात. तर इलेक्ट्रोस्टॅटिक अट्रॅक्शन प्रेझेंट इन टू दॅट. ओके, सो प्रायमरी चार्ज कॅन नॉट अट्रॅक्ट अन इक्वल अमाऊंट. इक्वल अमाऊंट मध्ये ते त्याला सेटलमेंट होण्यासाठी वेळ लागतो. काउंटर चार्ज घेण्यासाठी त्याला वेळ लागतो. सो पार्टिकल सी, दिस इज द कोलायडल पार्टिकल. ओके, एक्सक्यूज मी, कोलायडल पार्टिकल. तर कोलायडल इथे जो डार्क पार्टिकल तुम्हाला दिसतोय तो काय आहे, कोलायडल पार्टिकल आहे. तर हायली निगेटिव्ह कोलायडल पार्टिकल इज प्रेझेंट हिअर. अँड फर्स्ट ऑफ ऑल पार्टिकल अट्रॅक्ट अपोजिट चार्ज आहे अँड रिपेल लाईक चार्जेस. तर त्यामध्ये सगळं अट्रॅक्शन कसं होईल, इथे जे अल्युमिनियमचे आपण सपोज केमिकल ऍड केलंय, तर त्याचे पॉझिटिव्ह चार्ज ते पार्टिकल्स असतील ते सगळ्यात आधी त्याला अट्रॅक्ट करतील आणि एक अशी स्टर्न लेअर तयार होईल. आता स्टर्न लेअर म्हणजे काय, एक अशी बाउंडिंग लेअर तिथे होते की ज्याने त्याचा पोटेन्शियल, जो अट्रॅक्ट होण्याचा पोटेन्शियल नव्हता, तो तिथे ड्रॉप डाऊन होतो आणि ते अट्रॅक्ट होत जातात. ओके, अट्रॅक्शन त्यांचं वाढतं आणि त्यामुळे सेटलिंग न्यूट्रलायझेशन वाढतं आणि ते फ्लॉक फॉर्मेशन होण्यासाठी मदत करतं. ओके, सो हायली निगेटिव्ह, डिफ्युजन म्हणजे काय, निगेटिव्ह पॉझिटिव्ह, निगेटिव्ह पॉझिटिव्ह, निगेटिव्ह पॉझिटिव्ह असं एक जाळं तिथे तयार होतं. डिफ्यूज लेअर मीन्स निगेटिव्ह पॉझिटिव्ह, निगेटिव्ह पॉझिटिव्ह असं चार्ज असलेलं असं नेटवर्क तिथे तयार होतं. ओके, सो दॅट इज a generation of diffuse layer in which particles charge get neutralized, so that त्याच्यामध्ये आपल्याला जे जेलेटिनियस मास पाहिजे, इन्सोल्युबल जेलेटिनियस मास तिथे तयार होण्याची तिथे ती क्षमता त्यामध्ये येते आणि त्यामध्ये अट्रॅक्शन. ओके, सो थ्रू दिस इमेज आय होप यू आर गेटिंग. ओके, so neutralization is takes place. So you can see which are the particles which are having due to van der Waals force निगेटिव्ह चार्ज, सेम पार्टिकल्स असतील, सेम निगेटिव्ह चार्जचे पार्टिकल्स ते काय करतात, एकापासून दोन्ही डिस्ट्रॅक्ट करतात, म्हणजे अट्रॅक्ट होत नाही. ओके, सो विच आर हॅव्हिंग पोटेन्शियल हाय, द रिपल्शन इज स्ट्रॉंग इवन ॲट लार्ज सेपरेशन्स अँड पार्टिकल डू नॉट कोलाइड. When surface potential means when we are adding chemical, surface potential are getting low, the particles can approach close enough and collide and stick, and they are carrying its agglomeration, which we call settlement. Okay, so this is takes place into water, raw water, when we are adding particle. So the formation of electrical double layer, which will occurs via attraction of opposite charge counter ions by primarily surface charge, and then diffusion of counter ion away from the surface. Okay, so you can see surface charge. So charge ions which are commonly negative adsorbed on the particle. Okay, so surface charge means एकदम इनिशियल लेअर जी असते ती आधी त्यामध्ये निगेटिव्ह चार्ज असतात म्हणजे we have to attract to them, then such counter ions will attract to complete colloidal particle layer, and then stern layer is present. So counter ions, that means opposite charge attracted to particle surface and closely attached to it by electrostatic force. So that electrostatic force will act to them, and this complete diffuse layer will be formed. That means the film of dispersion medium. That means both the layer, positive, negative, uh, both the layer, complete layer will be formation. So diffuse layer contains free ions with a higher concentration of counter ions. Okay, so the ions of diffuse layer are affected by electrostatic force of the charged particle. Okay, see, in this negatively charged particle, that means colloidal particle have complete negative charge. Then we are adding aluminum, aluminum sulfate. So aluminum have 3 valency, so the positive charge get attracted. Then negative positive diffuse layer will be formed surrounding this. That is very much important to understand. This bound layer called stern layer. You can see the stern layer, stern layer, the stern potential. Potential म्हणजे त्याची जी stern layer you can see फक्त पॉझिटिव्ह चार्ज आहे ते म्हणजे काउंटर आयन्स तिथे अट्रॅक्ट होत आहे आधी, आणि मग त्यांची एक डिफ्यूज लेअर फॉर्म होते. ओके, सो दॅट इज टू बी अंडरस्टँड. द सरफेस चार्ज ऑन कोलायडल पार्टिकल गिव्स लॉंग टर्म स्टॅबिलिटी. याच्याने त्याला लॉंग टर्म स्टॅबिलिटी येते आणि पार्टिकल्स you have to settle down. So that is completely takes place into this water. Okay, so that is electronic double layer theory. Okay, so in this image you can see this is double layer theory. Okay, negative charge, then it is attracted with the positive charge, and then a complete diffuse layer will be formed. Okay, so I hope you understood this concept, which by this coagulation carry out effectively. So what is flocculation? आता हे जे coagulation झालं त्यामध्ये settlement agglomeration होतं ते after certain time. So that is flocculation. Flocculation is agglomeration of destabilized particle. म्हणजे न्यूट्रलाइज जे झालेलं आहे ना, त्यांनी न्यूट्रलाइज झालेल्याचं जमा करायचं, ऍग्लोमरेशन करायचं काम हे फ्लॉक्युलेशन थ्रू होतं. मीन्स ते जमा झालंय परंतु त्यामध्ये कम्प्लीट प्रेसिपिटेशन जे होत आहे त्या प्रेसिपिटेशनला फ्लॉक्युलेशन म्हणतात. ओके, सो न्यूट्रलायझेशन म्हणजे कोॲग्युलेशन and flocculation means agglomeration. So this is the agglomeration of destabilized particle into large size. After certain time it will increase their size. Okay, and this gelatinous mass will be त्याचं जे काही ग्रॅव्हिटेशनल फोर्समुळे ते नंतर खाली सेटल होतं. ओके, ते जड होतं, ते म्हणजे त्याचं साईज जे होते ते इन्क्रीज होते आणि हेवी झाल्यामुळे ते सेटल होतं. ओके, सो इट विल गेट सेटल डाऊन. So that is flocculation. So when it is carried out in this process, so we have to know, we have to understand clariflocculator. Clariflocculator nowadays we are using in water treatment plant. In that we have to first of all add the coagulant into that water. After coagulation process, chemical reaction takes place, and after chemical reaction that floc settlement it is carried out at the bottom, that is flocculation. So floc settlement is flocculation which takes place into the tank. Okay, so you can see whatever coagulation which takes place, the second stage is enhancing agglomeration. म्हणजे त्याची साईज वाढवायचं आहे, साईज वाढवून त्याला entangle करायचे. Colloidal particles when get entangled to each other, they carrying their heavy size and they get settled down. Okay, so very much important thing, how what are the factors affecting this coagulation, effective coagulation? It is completely depend upon raw water quality, type of coagulant, when what is which type of coagulant you are mixing. Okay, त्याच्यामध्ये तेवढी कॅपॅसिटी असली पाहिजे त्या coagulant मध्ये की it will attract those colloidal particle. So which is very much important. आपल्याला काय कलर, odor, taste ती सुद्धा रिमूव्ह करायची आहे. त्यामधले कोलायडल पार्टिकल्स तर रिमूव्ह करायचेच आहे, तर त्यामध्ये तेवढी कॅपॅसिटी असली पाहिजे. दॅट्स वाय टाइप ऑफ कोॲग्युलंट इज व्हेरी मच इम्पॉर्टंट. ॲज आय हॅव टोल्ड यू, alum, filter alum, sodium aluminate, ferrous sulfate, ferric chloride, these types of coagulants we have to use. Okay, that's as I told you, salts of aluminum means some salts of aluminum we can use, some salts of iron or ferrous we can use. So the different chemicals may be used for coagulation process. So these coagulants are completely that much capable to carry out that action. Okay, so that type of coagulant is very much important. Second, quantity or dose of coagulant. When you are adding that coagulant into that water, आता आपल्याला कसं समजायचं की किती डोस ऍड करायचा, किती coagulant we need to add to treat that water. So for that purpose we need to carry out jar test. jar test आपल्याला म्हणजे एक ऍबिलिटी टेस्ट करावी लागते की आपल्याला coagulant ऍड करायचं तर आहे, पण किती करायचं. तर त्यासाठी आपल्याला टेस्ट घ्यावी लागते की टर्बिडिटी किती आहे, what is the raw water turbidity, and we have to check that, and as per that we have to decide dose of coagulant. So from jar test we can we can achieve the graph. Okay, optimum dose of that particular coagulant. तर त्याचा एक ग्राफ मिळतो आणि त्याच्यावरून आपण डिसाइड करतो की डोस ऑफ कोॲग्युलंट किती द्यायचा. ओके, सो आर यू अंडरस्टँडिंग? हॅलो हॅलो.
Yes, ma'am. Yes, ma'am.
Okay, so dose of that we will study in the later part. How this chart is carried out. Practical session we will discuss that. Okay, so quantity and dose of coagulant we have to understand. So it is completely depend upon